The IEEE 81 standard outlines a specific methodology for measuring ground resistance, employing the fall of potential method. This method is a widely accepted technique for assessing the effectiveness of grounding systems, which are critical for electrical safety and equipment protection. Understanding the principles behind this method and the details provided in the IEEE 81 standard is essential for anyone involved in designing, installing, or maintaining grounding systems. The fall of potential method involves injecting a test current into the ground through an auxiliary electrode, commonly referred to as the current electrode. Then, the voltage potential is measured between the ground electrode under test and another auxiliary electrode, known as the potential electrode. This potential electrode is placed at various distances along a line between the ground electrode and the current electrode. By analyzing the voltage measurements at different distances, the ground resistance can be determined. The IEEE 81 standard provides detailed guidelines on the placement of these electrodes, the selection of appropriate test currents, and the interpretation of measurement results. The standard specifies that the current electrode should be placed far enough away from the ground electrode under test so that its presence does not significantly influence the measured resistance. A common rule of thumb is to place the current electrode at least 10 times the diameter of the ground electrode away from the ground electrode. The potential electrode is then moved along a line between the ground electrode and the current electrode. Measurements are taken at several points, typically at 61.8% of the distance between the ground electrode and the current electrode. The resistance value obtained at this point is often considered a good approximation of the true ground resistance. However, the IEEE 81 standard recommends taking multiple measurements at different distances to ensure accuracy. The standard also addresses the issue of stray currents in the earth. These currents can introduce errors into the resistance measurements. The IEEE 81 standard recommends using alternating current AC test signals rather than direct current DC signals to minimize the effects of stray currents. The frequency of the AC test signal should be chosen to avoid interference from power line frequencies or other sources of electrical noise. Furthermore, the standard provides guidance on the selection of appropriate test equipment. The equipment should be capable of delivering sufficient current to the ground and accurately measuring the resulting voltage potentials. The internal resistance of the voltmeter used to measure the voltage potential should be high enough to avoid loading the circuit and affecting the measurements. The IEEE 81 standard also addresses the safety precautions that should be taken when performing ground resistance testing. High voltages and currents can be present during testing, so it is essential to follow proper safety procedures to avoid electric shock. Workers should wear appropriate personal protective equipment, such as insulated gloves and boots. The test area should be properly barricaded to prevent unauthorized access. The IEEE 81 standard is a comprehensive document that covers all aspects of ground resistance testing using the fall of potential method. It is essential for anyone involved in grounding system design, installation, or maintenance to be familiar with this standard. While access to the full standard may require purchase or library access, understanding the underlying principles of the fall of potential method can be achieved through various educational resources and online materials. Grounding systems are designed to provide a low impedance path for fault currents to return to the source. This helps to protect people from electric shock and to prevent damage to equipment. A well-designed grounding system will minimize the voltage rise on equipment enclosures during a fault, reducing the risk of electric shock. It will also provide a path for fault currents to flow quickly and safely, allowing protective devices to trip and clear the fault. The fall of potential method is used to verify that a grounding system is effective in providing a low impedance path for fault currents. By measuring the ground resistance, it is possible to assess the overall quality of the grounding system. A low ground resistance indicates that the grounding system is effective in providing a lower impedance path for fault currents. A high ground resistance indicates that the grounding system may not be effective in providing a lower impedance path for fault currents. In addition to the fall of potential method, there are other methods for measuring ground resistance. One common method is the clamp-on ground resistance meter. This meter measures the resistance of a ground loop by clamping around the ground conductor. The clamp-on meter injects a test signal into the ground loop and measures the resulting current. The resistance is then calculated using Ohm's law. Clamp-on ground resistance meters are convenient for testing ground loops without having to disconnect the ground conductor. However, they are not as accurate as the fall-off potential method. The accuracy of the clamp-on meter depends on the quality of the ground loop and the presence of stray currents. Another method for measuring ground resistance is the three-point method. This method is similar to the fall-off potential method, but it uses 3 electrodes instead of 2. The 3 electrodes are placed in a line, with the ground electrode under test in the middle. The current is injected into the ground through the 2 outer electrodes, and the voltage potential is measured between the ground electrode and one of the outer electrodes. The resistance is then calculated using Ohm's law. The three-point method is more accurate than the fall-off potential method, but it is also more time-consuming to perform. The choice of method for measuring ground resistance depends on the specific application and the desired level of accuracy. For critical applications, such as power plants and substations, the fall-off potential method or the three-point method is typically used. For less critical applications, such as residential and commercial buildings, the clamp-on ground resistance meter may be sufficient. Regardless of the method used, it is essential to follow proper safety procedures when performing ground resistance testing. High voltages and currents can be present during testing, so it is important to wear appropriate personal protective equipment and to barricade the test area to prevent unauthorized access. Ground resistance testing is an important part of ensuring the safety and reliability of electrical systems. By measuring the ground resistance, it is possible to verify that the grounding system is effective in providing a low impedance path for fault currents. This helps to protect people from electric shock and to prevent damage to equipment. The IEEE 81 standard provides detailed guidance on how to perform ground resistance testing using the fall-off potential method. This standard is essential for anyone involved in grounding system design, installation, or maintenance.